Welcome to 100% Epic. I'm Chris. Today we're going to be doing the ultimate Laforge build. And by ultimate, what I mean is head tracking patch antenna goodness. Stay tuned as we walk through this DIY project you can do at home. Okay, first thing you're going to be saying is, why do I need a head tracking patch antenna for your goggles? If you're familiar with the Laforge system, it is a diversity system for the Fat Shark goggles. You want diversity so you can run a patch antenna, circuit polarized antenna, two patch antennas, different types of antennas for different type of flying. But the problem is patch antennas are very directional, meaning they've got to stay somewhat level, pitched up slightly, and in the general direction of where your aircraft is flying. If you're an FPV pilot like myself, when you fly, your head is like this when you're flying around. Before that, our diversity systems, before the Laforge, were these big heavy tripods that you had to lug around. But they were stationary, so you're able to angle your patch antennas in the general area you're flying. So they were great as far as a stable video signal, but terrible for portability. So the Laforge system was a great product when it came out, but the problem is like I said, when your head is pointing at the ground, you're not really utilizing that secondary patch antenna to its full advantage. So I thought, what can we do to improve this? And the Millennium Falcon upgrade to the Star Trek Laforge was born in. And obviously you can see why I'm calling it the Millennium Falcon. But it's just a module, and we're utilizing the head tracking bay. And it just snaps in, and it just allows that patch antenna at any angle to stay level as you move your head around in FPV fly to take full advantage of your Laforge diversity system. So stay tuned, we're going to walk through the build right now. Alright guys, let's go over what we're going to need to get this build going. First thing is just a small micro switch, 2 position, smaller the better. Needs to be able to handle at least 1 amp. Most of them in this class will easily handle that. I actually scavenged this from a toy and just pull it out, cut the wires, but you can pick these up at Radio Shack or any of your electronic hardware stores, or just scavenge one yourself. You're going to need a 5-volt beak, smaller the better, at least a half amp, because we are going to be running a servo off of that and our FC as well. This particular one is shrink wrapped and already has wires soldered right up to it, so it's fairly nice, very small, easy to use BEC. It's actually the smallest one that I know of. You could also do like a Plulo, but you just shrink wrap it, solder the wires onto it. And I know I'm killing that name, I don't know how to pronounce it, but those beaks work extremely well as well. You're going to need a micro FC 32-bit compatible with CleanFlight. Smaller the better. This particular one is the 10 DOF. It comes with a nice mounting case, so I actually did my CAD work around this particular FC. You can pick this one up from Hobby King, and it works extremely well. It's about the smallest one that I know of as well with the beak. Also, you're going to want a high quality 5-gram servo. Any 5-gram servo will work on this. This particular one is made by Blue Arrow. It's a digital full metal gear, real high torque, just 5-gram servo. I like this because the higher quality servos and the digitals have less ratcheting as they're moving. And since this is going to be on your head, you don't want to have audible sounds of that servo moving or that ratcheting coming through. And this servo is extremely quiet, extremely smooth, extremely high resolution, and like I mentioned, ball bearing and full metal gear. So I recommend one of these servos, or just any other quality 5-gram servo that you can pick up. Now, of course, you're going to need a 3D printer, or a buddy that has a 3D printer, and a pair of goggles. I geared this around the Fat Sharks with the Laforge, but there's no reason that this setup wouldn't work on any other goggle or adaptable to even any of the visors itself. The concept is all there. You can and work with it. I'm going to go ahead and put the CAD files as well as the STL printable files in the link below on this video, so you're going to be able to download and use those files. So let's go ahead and get into the build. Alright, so we need to get all this into our 3D printed housing as well as a couple components into the goggles. Let's go ahead and start with the goggles. First thing you need to do is just go ahead and pop off your 2 side doors. You just pop them off using your hands, as well as just the faceplate. If your goggles has a faceplate, just go ahead and flex and pop it and work your way to the center, and it snaps right onto the right off the goggles. Go ahead and set those to the side. Now if we roll it over and take a look at where your 5.5 12-volt in jack is, this is actually your head tracker bay. Right in here is your Trinity head tracker. This was an option part from Fat Shark. Not all goggles have it included, but most of them have it as an option. You can plug it in. But to remove it, you just lift up on the head tracker, and it actually just removes right out of the way. Go ahead and set that aside and save it for a rainy day. Now if we take a look inside the goggles in this bay, we've got lots of room, and that's where we're going to go ahead and tuck our 5-volt beak right inside there. In order to get our 12 volts to our BEC to give our 5 volts to our FC, we need to go ahead and just tap into this 5.5 jack. In order to do that, I'm going to have to just open up utilizing these 3 screws, and we're just going to go ahead and solder up a connector. I'm just going to use a old servo lead right over here. I'm going to clip it right here. I'm going to use this as our 12 volts here, and then this side on our BEC. That'll allow me to remove this BEC if I ever had to, so it's not a permanent installation in the goggles other than this 12 volt jack that'll just be laying right in on the inside, which could be utilized for many other options in the future. And like I said, we've got plenty of room right over in there, so it's not going to hinder anything as far as goggle operation or returning it back to stock as far as that's concerned. So let's go ahead and get started. Okay, with the screws out, just carefully lift off the top of your goggles and flex that to the side. Just be careful, there's a couple ribbon cables. We don't need to fully disassemble these goggles. All we're really going to do is take out this board just to make it a little easier to solder. There's just one screw right over here that holds that in. And we're able to lift that up. We've got a connector right over here. Just pop that off. And one right up here. Go ahead and set the rest of the goggles to the side. Let's take a look at this. Right here is our 5.5 barrel 12 volt in. The center pin right here is our positive, and that is our negative. I'm going to go ahead and just take the servo extension, clip it off, and get it soldered right on there. Okay, now that we have our goggles back together, we just need to check functionality as well as our voltage from our tap port that we just put on in there. You can see lots of room. We can just tuck that away inside the goggles. It's not going to interfere with anything, even if you want to put the original Trinity head tracker back on inside. So first thing I'm going to do is just go ahead and plug in my battery. And yep, I still have video. AV2 is showing on that 2D. So everything is functioning as far as that's concerned. Let's go ahead and check voltage out. I'm just going to go ahead and plug this in and check for our 8 volts coming from this. Here we go, 8.28, so no problems there. So we are ready to move on forward to the rest of the electronics which are going to be on this. Okay, so now we need to make sense of the rest of this wiring. Essentially, we've got power coming in from the mod we just did to the goggles via our servo extension that we clipped off. So this is the female end of that. So we'll go ahead and use that as power into our BEC. From the BEC, I'm going to put in another small connector so that I can isolate and remove the BEC if I ever needed to. As well as this is going to be tucked into the goggles itself, and I wanted to be able to have a separation point without the BEC. So we've got this connector, which is the male side of that, which is going to our switch, and then is going to our port that goes into our flight controller to turn on the power. So we just need to solder up this to this, this to this, this to the switch, and the ground bypass right over here, so the hot will be switching right over here. So let's get soldering. Okay, so in theory we've got power coming in from the goggles through our 5 volt beak to this connector, which allows us to isolate and remove the BEC anytime we need. This will tuck away inside the goggles themselves, and so this will be plugging into this box right over here. Inside this box we're going to have our switch, which is going to be mounted right inside there with the it coming out right over there. This is going to tag on over and plug into our FC to provide the power, and this plugs into our BEC. So we'll just go ahead and test our wiring, plug that into that, we'll grab the FC. Now I'm providing the 5 volts via the UART serial port on the FC. We'll grab our goggles, plug this in, and plug this in, see if it works. So our FC boots up. And if I turn the switch, it turns it off. So we are set to move forward with the soldering up the servo. What I want to do on the servo, because it has a little bit a different connector on there, pretty small leads, obviously it's just a 5-gram servo, is I've already repinned the wiring that comes with the FC. Meaning that I'm just taking negative, positive. I've removed the rest of the PWM out for the motors, and I've actually only tied into port 2, which is going to be our pitch for our FC. So that'll be providing our PWM out to our servo as this actuates itself. But what I want to do is go ahead and cut and solder this to this, so we get rid of all this extra wiring right there. Alright, so I have the BEC tucked away into the goggles. There's actually a hidden pocket right up in here that isn't being utilized on the top of your goggles, and you can actually access that right here through here. I just fed the BEC right up in through the top, and then chased it in with the servo lead extension wire right over there, and our power out is right here, leaving this entire space completely open. So if we wanted to plug the original Trinity head tracker back in and utilize that at a later point, we could do that if we're not using our head tracking for the Laforge. So nice clean install, doesn't change anything if you want to revert back to original equipment on the goggles itself. And if you wanted to remove the BEC, just unplug it here and snake it right on out, and you are all set. Okay, next is our mechanical setup. So what we need to do is install the power switch first, followed by the servo, and then the flight controller. We take a look, you can see it right here. There's a small little, you get it on the camera, light, you can see it. There's a small little lip that was 3D printed in there that lines up with this hole, and the switch just sits right in there. I'm just going to use a little hot glue gun to hold that in. Our servo just has the 2 screws that lock that in right there, and then the FC goes on top of it itself. I'll swap over to a CAD drawing real quick so you can take a look at how that, you can see it a little bit better, how that goes together. Okay, so this is a quick overview of where the components go inside the housing itself. Like I said, I'll post these files so you can 3D print them yourself. But the switch on that side and the FC and the servo, let me just change transparency on this so you can see how it mounts inside. So the servo, you've got clearance right in here, and then underneath the behind the servo and the FC in this little pocketed area right here is where you can tuck all the wiring, and there's a slot right here, so the power wires can come right out here through here. And the servo linkage that goes to this plate right here just goes right through there, and it allows your servo arm and the plate to actuate back and forth. Other than that, that's it. That's how it installs inside the housing themselves. Okay, so here we go. I've got the completed unit. I've got the servo, all the linkage, the bearings, the front rotation plate, FC, switches all mounted in there. We've got it all soldered up, so we just have the single power. So this is the complete unit all by itself. Pretty small, about the size of a standardized servo actually. And then of course we've got our power lead coming in. So we're just going to plug that in. Tuck our wires back in here. Line it up. There we go. Give it a snap and the unit is installed. I'm going to call this the Millennium Falcon upgrade to the Laforge. Little crossbreed between Star Trek and Star Wars. There we go. Let's go ahead. Alright, here we go. I got the module plugged in. I went ahead and put the Laforge on it and the little patch on there. Just like any flight controller, what you need to do is it's got to calibrate the offset between the gyro and the accelerometer. So when you turn it on, you just lay it on a flat surface, turn it on, wait. When it pops up, it's been calibrated, we're ready to rock and roll. And probably can't see it from this angle, but as I tilt the goggles, you can see it is holding still. So what I'm going to do at this point, here, we'll move it at that angle, you can see it's working. Works actually pretty good. So what I'm going to do at this point is go ahead and disassemble this, paint it up to match, and do a little cleanup on it. Go ahead and get the other module put in, and I'll show you the finished product. Okay, quick update. Went ahead and painted this. I knew there was going to be revisions, so I didn't take the time to sand and polish it and paint it very nicely. Ended up actually just using some cheap nail polish remover, and it ended up wicking up some of the color, and so it actually came out pinkish against the goggles. If I hold one of the goggle doors, you can actually see it. It has a pinkish hue to it. So I didn't like that, so I ended up reprinting a brand new one in bone white ABS. Beautiful print, came out very nicely, as well as I did a couple revisions. I widened the servo gap in there. I had to sand the original one a little bit, as well as beefed up these joints on the edges right here so it allowed to flex a little more without having any cracking issues on the sides, as well as being a little more robust. So anyway, I just need to transfer all the original components from here to here, and this is going to be our finished product right here. Alright, so here we have the completed one. I'm actually glad I messed up the other one because I was able to implement some mods that I've already done to it. This print came out absolutely fantastic, and like I said, it's printed in a bone white ABS, so coloring on it matches good enough. I'm not going to go ahead and paint this one up, and the surface finish on this one is a high-res print. Looks absolutely fantastic, so I'm not worried about it. You can see the final assembly, Servo FC, linkage. We've got our bearings right over here, and then just our power leads coming on out, and then our front plate where the Laforge goes on there, and of course our on and off switch. What's really nice and handy about having these adapters in there and the BEC tucked up inside here, if we're at a race event where it has a dedicated ground stations for you to utilize and you don't need to use the Laforge, you can just snap this off, put your standardized door on there, and just use it that way. If not, you just pop your door off, plug this in, snap it in, plug in your Laforge diversity, and you're all set to run diversity on your Laforge. Very, very user-friendly. All right, enough of that. Let me go ahead and finish putting in the Laforge setup, get all the wiring run on that, and then we'll go ahead and take it out for a test flight, see how it actually works in the real world. Thanks for staying with us for the build, and I think it turned out pretty good. I went ahead and created a couple extra parts just to polish up the look for the Laforge, or the Millennium Falcon upgrade, as I'm calling it. And that is a Laforge styled front wire protector that goes along to the front. It's TPU printed, so it just wraps and follows that curve right along the front side, as well as a left side door. I couldn't find any that fit the V2, V3 on Thingiverse or anywhere else because of that screen protector on there, so I went ahead and modified that right over there. So that is everything. Now immediately after this little ending intro, whatever you want to call it, is the Clean Flight tutorial on how to set up your Clean Flight controller as far as the software to make it work with this head tracking. So go ahead and stay tuned for that if you went ahead and built the rest of this. Now there's a poll going to be right up here, as well as leave comments below if you want to see this basically developed a little bit further, clean it up, make it a little more Star Trek-y or Star Wars with the Millennium Falcon, as well as we could do something a little more sinister with it if you want. And I'm thinking, you know, something a little apocalyptic or post-apocalyptic with it. Make the ultimate goggles with that. Or we could take this and ditch it to the side and go with something a little bit more popular, which is the mini whoops out there. And I've got the ultimate whoop right here. This is 500 milliamps, 8.5 millimeter motors, clean flight. So I've got air mode, the whole 9 yards. Race it indoor, outdoor, and you can build this for a lot less than you can build one of these. Go ahead and leave that in the comments if you want to see this built. There's a lot more tutorials as well as comparison videos coming out, so stay tuned. Like and subscribe. Thanks for watching. We'll see you guys next time. Let's go over the Clean Flight settings that we're going to need for this head tracker. So first thing, go ahead and jump up to Clean Flight and connect to your FC. Make sure you have the latest version of Clean Flight. I think 1.9 is probably acceptable, but doesn't hurt to upgrade to the latest. Jump over to configuration, and your Clean Flight is probably defaulting to Quad X, but go ahead and change it to Gimbal, which is right there. When you do that, motor stop, one shot, all of this should be disabled. If you slide on down to the bottom, the other thing you need to click on is Servo Tilt. Right there, everything else can be off. Next thing we need is to go to right over here, modes, and set up arm, slide your maxes to the max range, and set it to one of your UX channels. And what this will allow it to do is, as soon as it receives power, it's going to go ahead and arm the flight controller, so we don't need to use the the yaw to arm it. It'll automatically be armed at all times. The other thing you have to do is do the exact same thing, UX1, slide your sliders all the way over to cam stab. So as soon as this is powered up, it immediately arms and goes into cam stab, which starts actuating our servos for gimbal control. So that's our mode adjustment. Next would be servos. Now this is where it gets a little confusing. I have, because the FC is actually turned on its side, I have it set to Servo 2, which is actually my roll. I'm sorry, well, it's Servo 2, but it's 0. It starts at 0, and then Servo 1, which is actually PWM 2 on the board itself. Now, mid, min, and max, this sets up your throw of your servo, how far it can actuate both ways. So you're going to want to set these up for the mechanical values of how you put your servo in there. You know, if your servo arm is, one tooth over to the right or to the left, this is where you can set up those mechanical limits. It's best to leave the screw out of the servo arm and kind of reduce these quite a bit when you start, and then just keep bumping up the numbers on the minimum, bumping down the numbers, on the max bumping up the numbers until you start hearing the servo bind up a little bit, back it off a few. Now the mid is the interesting one. This is where you're going to set the 0 point for the servo. So when you arm your goggles, your gyro and your accelerometer basically take the difference, and that's your 0 point. Now when you put your goggles, meaning your level point, when you put your goggles down on the ground, if you have a faceplate, they don't sit level. And so this is where you correct for that levelness. So as soon as it arms, it takes that gyro bias, accelerometer bias, and then it applies this correction right here, which then where it knows where the level is, and it starts off right there. So after you're done and you build your set, you can come in here, and once your servo arms, it'll pop up, and then this is where you can tweak it to be level. Up and down right there. Now don't worry about this. This would be for gimbal right over here, and then this is the other one to take a look at, which is your rate. Now you can see that this one's negative where this is positive. Basically, if it's a negative, the servo goes one way, and to reverse it, saying it's going the wrong direction, you go positive or negative, whatever you need depending on your servo. So that's how you reverse it, and I'll just drop down on this one, and you can see it drops all the way down to 0, and then it starts going negative. Now the rate is a setting that you want to adjust, and this is how much FC movement there is in relation to how much servo movement there is. It doesn't adjust your endpoint adjustments, but basically this can exaggerate or dampen the servo motion, meaning that if your servo needs to actuate further than actual to keep it level, depending on the geometry, this is where you can adjust that. So if you had it at 100%, this rate at 100%, and you were to move your head, say, up, if it overcompensated for the amount you moved up, meaning it was started to pitch itself down instead of keeping level, you can reduce this rate, and it's the relationship between the actual board being how much it moves to the mechanical throw of how it pops out, or how it comes out over here. So if you were to reduce this, it would take a lot more head motion to make the servo move to its full extent, or vice versa. If you increase this to the max, it takes very little head motion to make the servo go to these maxes and minimums right over here. So this is where you just basically set up your mechanical 0 point and your min and max, and then this is where you adjust how much your head actually moves to keep it level itself, and that's it. Other than that, the rest of this you really don't need to worry about. Make sure you click save on that, disconnect, and you are all set. One other thing, if you're not familiar, if you go over to configurations, this is where you can set up your board to be forward, back, upside down, however you can fit it in the goggles. You can adjust this right over here. In this case, you can actually see my board is upside down, and the reason for that was so I could get to the port for the FTDI cable, and so I just flipped it over so the port was facing outside. Other than that, that's everything you need to know about setting up for the gimbal. If you have any questions, just put them in the comments. I'll respond to them. Thanks.